The focus of our research is to deliver and to create bioartificial pancreas to achieve this is an overarching aim of my group, but to achieve this aim, we are employing several strategies of the tissue engineering, such as creation of the 3D spheroids, organoids, insulin-secreting organoids, incorporating inside several types of the cells. Then we are providing these structures with extracellular matrix components, because it turns out that the extracellular matrix is crucial for viability and the function of the islet. So we provide these molecules through the delivery of the hydrogels or a cellular matrix. We decellularize the scaffolds and we reseed them with the organoids or the islets. Then what we do, we also try to pre-vascularize these constructs before we transplant them, because in the first days after the transplantation, they don't receive direct blood supply, so they do need the oxygen, they do need the nutrients to penetrate the construct. So we do pre-vascularize them before transplantation. And then the final task of our group is to modulate immunity, to protect our graft from host immune system to be rejected. So for that, we employ the genome editing through the CRISPR-Cas state-of-the-art technique, and we try to combine these components and assemble into the bioartificial pancreas. So now, to achieve this task, we are using, of course, the placenta and its derivatives. Because the placental cells are known to modulate immunity, because when the fetus is developing in the mother uterus, it's not getting rejected, even though it's considered as a semi-allogenic transplant. So because these cells, they are producing special molecules that are protecting the baby from the mother's immune system. So these characteristics of the cells are interesting for us, and we are trying to utilize them in our system. Another thing is to use the extracellular matrix scaffolds from placenta to produce the hydrogels and the cellular scaffolds. So why? Because they do contain the similar molecules of extracellular matrix, like islet and the pancreas. So these are the things that we are doing and we are trying to do. Now, we already reached some milestones. For example, we did already produce organoids, insulin-secreting organoids that we have transplanted into the diabetic mice. And what we saw is that these organoids, composed of the amniotic cells derived from placenta and islet cells, were functional. So, and they engrafted well, they got vascularized quite fast, and they corrected the type 1 diabetes, so in mice. Now, another thing what we have produced, we produced the hydrogels, and we incorporated our organoids into the hydrogels, and what we saw, that organoids embedded in hydrogel were superior to organoids cultured without hydrogel. And then we transplanted these structures in the mice again, and we saw that this was indeed curative for the mice that were rendered diabetics through the chemical manipulation. So these are the milestones we have reached, and now we have still a lot of things to do in terms of the immune modulations and in terms of the functional organ assembly, which will be complete. And for this, we will need to still work on these cells and to edit with CRISPR-Cas technique to amplify their immune suppressive properties.